So just adding on to what we did yesterday, we're going to keep the same, same thought process. We know how to solve multi-step equations. So we're now solving multi-step inequalities. So we kind of just follow the same rules with one exception. We have to worry about if we multiply or divide by a negative number. And if we do, we have to do what? Switch the sign. We got to reverse that symbol, don't we? Well, today I'm going to tell you that sometimes, remember yesterday we always said, let's take care of the addition or subtraction first. Let's undo that first. And then let's do the undo the multiplying or dividing. Today I'm saying to you, sometimes, and this is important, you guys, it doesn't happen every time when you're solving these problems. But you got to be able to look at a problem and say, you know what? I think this is one of those times that I should undo the division before I undo the addition or subtraction. Because, in other words, the variable is involved in a fraction problem, isn't it? And what does the fraction bar mean? What operation does the fraction bar mean? Dividing. So that really says x plus 5 is being divided by 2. So, since x plus 5 is being divided by 2, we can't just subtract that 5 out of there and get rid of that 5 first, because it is part of that x. It's got to be added to that x, and then that has to be divided by 2. So we can't subtract the 5 this time. We have to take care of the fact that we have that x plus 5 being divided by 2. So how do we undo dividing by 2? Multiply by 2. So we're actually going to take both sides of this times 2. So 2 times, and we're just going to put in parentheses so that we can see. This is the original. This is how it looked. And we're taking it times 2. And on the other side, we have to do the same thing. 2 times, and we're just going to put that 3 in parentheses to show that's what was there to start with. So all I'm showing you with those parentheses is the parts that are in parentheses are the original problem. And we're doing the same thing on both sides. We're taking both sides times 2. And the reason that we're doing that is because then we can get the 2 that's down here to cancel out with that 2 that we multiplied by. So the 2 that was in that denominator cancels with that 2 we multiplied by. And now we have x plus 5 and no more fraction involved. Did we multiply by a negative number? No. So we don't need to reverse the inequality symbol. And 2 times 3 is 6. Okay. So this time we did the multiplication first, and now we see we got to still undo that addition, don't we? Right?
How come the 5 doesn't turn into a 10?
How come the 5 doesn't turn into a 10? Oh, because this right here, this x plus 5 that is upstairs, remember, they're together. They're attached together. And so what's happening is when, in reality, we're taking 2, we can put it over 1. We can make that into a fraction. We're taking a fraction times a fraction. And remember, when we multiply fractions, I'm just going to come over here to the side and show you an example. When we multiply fractions, can't we do this right here? Let's make this a 2 up here just to make it more resemble what we just did. When we multiply fractions, can we cancel those 2's?
No.
Can this 2 cancel with that 2?
Yes.
And did we worry about that we didn't deal with that 1 that was up there? We didn't, did we? We didn't worry about that. It only had to cancel with one part. One numerator had to cancel with one denominator. So the same thing is happening here, Trey. We have one numerator canceling with one denominator. So we don't have to worry about that 5. It gets to stay with the x, okay? Any other concerns before we move on? Okay, then what are we going to do next?
Subtract 5.
Subtract 5 from both sides because 5 is being added. We undo addition with subtraction, and our solution is
X is greater than 1.
x is greater than 1. That's our algebraic solution, and now for our graph. Integer neighbor to the left,
0.
0. Integer neighbor to the right.
2. Open circle.
Open circle, okay.
To the right.
Shade to the right, okay. So x has to be any number greater than 1. Okay, so be careful now. Remember, when you look at the problems, you have to decide, when should I do this method versus what we did yesterday? And what's different about this one is there's that fraction involved, and that's probably going to be a good indicator to you that this is what you would do first. Okay? Okay, let's try the next one then. We have 1 minus 2n. That whole thing is being divided by 3. And it's greater than or equal to 7. What do you suppose we're going to do first?
Multiply by 3.
Multiply by 3. So we're going to take both sides times 3 to get that 3 out of the denominator. So we have 3 times 1 minus 2n over 3. The only reason we're putting that in parentheses is just to say, here's what it was. I'm not changing it at all. I'm just multiplying it by 3. If I do that on one side, I have to do it on the other side. What happens on the left side again?
That the 3 cancel itself out.
And those 3's cancel each other out. So we have what left?
1 minus 2n.
1 minus 2n. 3 times 7 classes?
21.
3 times 7 classes?
21.
Thanks. I know, you just want to be able to the punch, don't you, Isaac? Okay. We're going to have to work a little harder in this one than we did the last one, aren't we? What do you suggest our next move would be?
Add 2. Subtract 1.
Subtract 1? Okay. You know what did I suggest we probably should do to make sure we do the right thing? What can we do with that subtraction? Make it add the opposite, because then we can read it backwards. We can say, oh, that's a negative 2n, and added to it is a 1. So whoever said we should subtract 1 had a good idea, didn't they? So subtract 1, subtract 1. Do we ever have to worry about reversing the symbol when we're adding and subtracting?
No.
No. Hey, did we need to go back and think about, did we need to reverse the symbol when we multiplied by 3?
No.
Why not?
Because it was negative.
Yeah, because we multiplied by a positive, not a negative. Okay, so what's 21 take away 1?
20.
20, okay. What's our last maybe move?
Divide by negative 2.
Divide both sides by negative 2. Okay, so negative 2n gets divided by negative 2. 20 gets divided by negative 2. To show that you're going to do the dividing in that step. And then this is when your brain should say, okay, I just divided. I'm dividing by negative, so what am I going to have to do? Switch the symbol, and maybe what you need to do is just switch it right away so you don't forget. What's negative 2n divided by negative 2?
Negative 2. And
Isn't this just n?
Yeah, that's
Right?
10.
Yeah. And what's 20 divided by negative 2?
Negative 10.
Negative 10. Okay. Our variables on the left side, is that where we like it?
Yes.
Yes. So any reason to mess with it?
No.
No. So our answer is going to be n is what? What's that say? S less than or equal to negative 10. Okay, so negative 10. Integer neighbor to the left.
Negative 11.
Negative 11. Integer neighbor to the right.
Negative 9.
Negative 9. What kind of a circle should I put at negative 10?
Shaded.
Shaded in one. Okay. What numbers are less than negative 10?
Negative 11.
Negative 11 and those ones on that side. Okay. So questions? Okay, then we're just going to practice one more problem. Yes, Isaac?
Are you always going to multiply what's on the bottom of the fraction?
Yes, I'm gonna say yes to that. Okay, any other questions or concerns? Because these are the only two of this type we're gonna practice. Now we're gonna practice a different type, okay? One more kind. Okay, then let's go to the back and practice that one. So sometimes you will need to simplify before solving. In other words, we know that we can simplify sometimes by doing a property called distributive property. We can combine like terms, whatever we need to do to simplify it before we start doing the same thing to both sides. So Isaac, what do you want to do here?
Oh, I was just gonna say multiply the 4 by the 2 and the 4 by the x.
Yeah, but you know what, before I do that, I'm feeling like I might want to change this subtraction in here
Oh, to change the opposite.
to add the opposite so that I'm going to be more successful. Trey?
So would it be negative 8 plus, negative 8, yeah, negative 8 plus positive 4. It's only negative 1.
Positive 4.
X.
X, yeah, absolutely. So a negative 4 times 2, first of all. Negative times a positive is a negative, and 4 times 2 is 8. So that's where we get our negative 8. Then we have to take negative 4 times negative x. Again, we can just do this. We can say what's a negative times a negative?
Positive.
A positive. And what's 4 times x?
4x.
4x. And then is less than or equal to 8. Now, be careful. This might confuse you right here. We just did distributive property with a negative number, didn't we?
Yes.
And you might be tempted to think, well, we just multiplied with a negative number. I need to switch the sign. But are we solving right now?
No.
What are we doing?
I'm simplifying.
We're just simplifying it. Did we take both sides times a negative 4? No. So we don't have to worry about switching the sign right now. We were just simplifying. Now we're ready to solve. And now is when we have to have that by multiplier divided by a negative. Then we're going to switch the sign. Okay, so what do you think is going to be our first move in solving this? Add 8. If you have a negative number being added, add its opposite. So now our inequality reads 4x is less than or equal to 16. And our next move would be divide by 4. Because x is being multiplied by 4. We're undoing that. Okay, so what is our solution?
X is less than or greater to.
Oh, wait a minute. You can't have less than and greater. Can't work that way.
Less than or equal to.
Okay, is less than or equal to 4. Anybody think we should have switched the symbol?
No.
Why not?
Because we didn't have this.
Yeah, we didn't divide by a negative. We divided by a positive. Do we need to switch? Do we need to do any switching now? Do we like the way our solution reads?
Yes.
Yeah, the variable's on the left, so we can go ahead and start graphing. And hopefully by now this is getting to be just an extra step for you. You don't have to think too terribly hard about it anymore. Okay, so any questions or concerns about that one? Sometimes we have to simplify first. We did that when we were solving equations also. Okay, then we're going to call it quits, and I'm going to count on you to have your notes out while you're doing your homework, and I'm going to count on you to ask questions